Hello, my lovelies. It's Susanna, and today I want to show you how to solve this problem. Benny forgot the PIN for his debit card, but he had previously written down a note with some clues. Crack the PIN A, B, C, D. This is his note for his PIN A, B, C, D. He has written down some equations, and we have to find the values for A, B, C, and D. What do we know about such a PIN? Well, it's a 4-digit PIN, and each digit is going to be a number that ranges from 0 to 9. So we can keep that in mind, that A, B, C, and D are going to be numbers from 0 to 9. Let's take all our equations, write them in a system of equations, and let's solve this. Maybe we start by simplifying each equation first, if possible. The first equation, well, it looks okay like this. I don't want to simplify here anything. But in the second equation, for example, I have C here on the left side and on the right side. So I could simplify the second equation. I write it down as it is right now, but I want to bring this C to the other side, so I add C on both sides of the equation so that I have A here. This cancels out, and on the other side I have C plus C, which equals 2C. Okay, so from now on, instead of this second equation, I'm going to use this simplified version of the second equation so that my system of equations looks like this now. Can I simplify the other equations? No, not really. They look good so far. So how can we solve this system now? If we take a look at our equations, we have A here. So this equation is solved for A, and the third equation is solved for A as well. That's great, because if we know that A equals 2C, and here we know that A equals C times B, then automatically these orange parts have to be the same. So C times B has to be the same as 2 times C, because both of them equal A. Okay, so I have a new equation. I have C and B in here. And let's say we want to solve this equation for B. So I want to get rid of the C here. So my plan is to divide both sides of the equation by C. But we have to be careful. We don't know what C is. Could it happen that we divide by 0 here? Yeah, it could happen, because we said that our digits can range from 0 to 9, so C could be equal to 0. We don't know yet, but we are not allowed to divide by 0, right? So we have to make a case distinction here and have to take a look at a first case where we're like, okay, nothing bad will happen here. My C is going to be not equal to 0 in my first case, but then I have to make a second case as well where okay, now I have to take a look what really happens if my C is actually equal to 0. Let's start with the first case, but don't forget to take a look at the second case later on then as well. So first case scenario, our C is not equal to 0, which means that if we want to solve for B, we are allowed to divide both sides of the equation by C. Here, C cancels out and only B is left, and on the other side C cancels out as well and only 2 is left. So we found out that B equals 2, and we can figure out the other variables as well. Let's take a look at the first equation to find out D, because now we know that B equals 2, right? So we have 2 plus 2, which equals 4, and this is my D. So I found D as well. Let's use the last equation, the fourth equation, to figure out A, because we know that A over my B is 2 equals D, and D is 4. If I solve this for A, I just have to multiply both sides of the equation by 2, because then this cancels out and only A is left. And here I have 4 times 2, which equals 8. And then only C is missing, so maybe the second equation, if we use this, we have A equals 8 in here, and 2 times C. To solve for C, we only have to divide by the 2 here, so that we had 8 over 2, which equals 4, and this cancels out, and only my C is left. So I found A, B, C, and D, but because this was so chaotic right now, make sure to check each equation if they are really correct. So if we insert 2 in here, we have 2 plus 2, and does this equal 4 for our D? Yes, this works. What about the second equation? We have, for our A, we have 8. So we have 8 equals 2 times, what is our C? 4? Yes, 2 times 4 equals 8. This works. What about the third equation? We have, for our C, 4 times, for our B we have 2, which equals 8, and this is A. Yes, this works as well. And the last equation we have, for our A, 8 over 2 equals 4, and that is D. So each equation is correct with the variables we found. So a pin, a possible pin for Benny would be 8, 2, 4, 4. But is it the only possible pin we can find? We don't know yet, because we have a second case to take a look at. What really happens if my C actually equals 0? Can this be the case? Let's find out. If C equals 0, then we would insert 0 here for C, and here as well. Instead of C, we write a 0. So we have 0 times B, which equals 0, and 2 times 0, which equals 0. 0 equals 0. Well, that's correct. It's not wrong. So it's not that we have an error here somewhere where we're like, no, this cannot be the case. This is a correct statement. So it could be that C equals 0. Let's work with this then with the other equations. So if C equals 0, I have 2 times 0 here, so I have 0 on this side, which means that A is equal to 0 then as well. Okay, maybe that's possible. I mean, it could be. But if A equals 0, I can insert 0 here for A, so I have 0 here, I have 0 for my C here again, so I have 0 times B equals 0. Yeah, that's correct. 0 times something is always 0, so I have 0 equals 0 again. Not a problem. What about the last one here? If my A equals 0, I have 0 over B, which equals 0 in total here on the left side. So my D is also equal to 0. Would be an easy pin to remember, wouldn't it? But what about the first equation? If my D is actually equal to 0, so let's take the first equation. I have B plus 2 equals 0. What is my B then? I subtract the 2 on both sides of the equation so that I have solved for B, because this cancels out, and on the other side I have 0 minus 2, which gives me -2 for B, and this is not possible in a pin to have a negative number. So this case, it cannot B, so the only pin that is possible for Benny is the 8244. If you enjoyed my video, please give it a thumbs up. It helps me a lot. I wish you a wonderful day, and I hope to see you in one of my next videos. Take care!